Hey everybody, this is Larry. This is day 4 of the Leetcode Daily Challenge in February. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and so forth. Another update on the stock market. Hopefully y'all doing alright. Things are doing a little better, but today's problem is going to be the contiguous array from 525. Let's see, given a binary array nums, return the maximum length of contiguous subarray if you go number of zeros and ones. Okay, so the first thing to notice is that n is 10 to the 5th. So that means that n squared is going to be too slow. N log n will be okay if you could figure out an n log n algorithm, but that's basically my first intuition. So it's not brute force, because I think one thing that you always have to think about, maybe not in an interview, but definitely competitive, is what n is, right? Because if n is say 100, then just do n squared and you get it in and out 5 minutes, no problem. But for this part, yeah, we'll see the maximum length of a contiguous subarray with equal numbers of zeros and ones. I think I've done a similar problem like this in the past where I think the zeros and ones is very easy to fall into a trap, at least for me, especially if you have experience, where you're just like, oh, let's do a prefix sum, right? And because you already have zeros and ones, you're kind of like preconditioned to just do a zero to an array, do a prefix sum on zero and ones itself. But I think another way to think about this problem is to think about it instead of 0 and 1 as an alphabet. You can think about it as A's and B's, right? And then in that case, then it becomes more clear. The equal in numbers of zeros and ones, then you still have a prefix sum, but your prefix sum is not on 0 and 1, but -1 and 1, for example. And in that case, you're trying to find the longest instance where the equilibrium is matched, right? And what I mean by that is that what I mean by that is, let's say you have, I'm going to do alphabet, for example, as a case. But yeah, let's say you just keep a running count of these things, and then here, yeah, A is, let me write this legend down. A is equal to +1, B is equal to -1, right? Then in that case, the running count will go from 1, 0. Yeah, okay. Maybe writing this need more space. But yeah, this is -1. I'm just gonna write. How do I want to write this? I'm just gonna write -1, -2, back to 1, back to 0, and then 1, 2, oops, 3, 4, oops, 3, and then this is subtract 1, subtract 1, subtract 1, -1, -2, -3, and then back to 2, back to 3, back to 2, so forth, right? So dot dot dot. So that's basically the idea. And then in that case, it's not it is prefix sum in that you keep track of the running sum, but then it is keeping track in a greedy way the earliest that you have seen that delta, right? And what I mean by that is that, okay, let's say we're here, we're just looking at this A right here, right? That means that 2, I actually forgot this is, I think this is a -2. Like I said, okay, I'm a little bit sketchy on the notation, so that's my bad, friends. But yeah, this is -2, meaning that there are 2 more B's than A's. So then the question becomes, when was the last time there was 2 more B's than A's? Because if we kind of match that up to the last time there was 2 more B's than A's, then that means that everything in between is equal, right? Because well, not the last time. Well, the last time it is true, but all the times in which the count is -2, you have the answer. And in this problem, you want to get the maximum length, and the maximum length can be found in a greedy way, right? Because if you have a couple of indexes with -2, then the earlier it is, the longer the length it is, and that's basically the idea, right? So basically, yeah, hopefully that is a good enough explanation, because I think this is a little bit awkward, because maybe I should have left some space for a negative sign, but that's the idea, is that if you have the same number of a previous count that you've seen, then that would be your answer. And that's basically what I'm going to do here, because I think one trap that I have fallen into in the past, it's either this problem or a similar problem, is that I get stuck thinking about zeros and ones. and then I do a prefix sum adding 0 and adding 1. And then I was trying to do some math of like, okay, let's say you have a running count of 5, that means that 10 spaces back has to be good or something like that. I think you could probably still do it, but I think it's just the math is a lot more awkward for sure. And it's also not clear to me that that's correct. So yeah. But anyway, this will be good. So let's get started. So then first I have a scene hash table, and then as I said, we go for x in nums. We have a current for so current will keep track of the number of ones minus number of zeros, right? And then now, so if x is equal to 1, then that means that we increment by 1, else we decrement by 1. And yeah, so have we seen this before, right? So if current is in scene, then, we have to keep track of the best. So the longest is equal to, then best is equal to the max of the best and also the previous index, which we put on scene of current, and then the current actual index, so index minus this. And of course, we didn't define index, but we can just put it here as such, right? And then else, if we haven't seen this before, that means that this is the first time we've seen it before. So then we set it equal to this. And that's pretty much it, I believe. Yeah. And then we just have to return best. This is going to be, as you can see, this is linear time, linear space being this hash table, and linear time being going through the array once. I always forget about this, which is that we have to set scene of 0 is equal to, I want to say -1. And this is just to kind of offset. I mean, you could do the math, however, like for example, you keep track of index plus 1 instead. But the -1 is to represent, let's say we have a string of, stuff. The first index, or in this case, the negative index, will start up at 0, and then you go to the 1 and ... And in this case, this should match. So yeah, so this is a case that I did forget. I'm usually okay with it, but I'm okay at it, but I'm not perfect at it. I always forget the base. I wouldn't say the base case, but the starting case. Like I do it enough times, but also like I catch it half the time, say. So it's kind of not great. But yeah. Oops, quick one button. Yeah, this case seems I don't know if there's any weird cases. Maybe just like one number. But yeah, I don't know that there are any weird edge cases of what I'm doing other than maybe off by 1 or something. And these are kind of silly ones. So let's give it a submit, give it a go, and let's see. This problem twice within a month. Anyway, yeah, that's pretty much it. Let me know what you think. 675 streak, yay. Like I said, this is going to be linear time because, this is just a for loop. We look at each element once, and linear space, which is, in theory, if this is all A's or all B's, or I guess in this case, 0s and 1s, scene would contain 1 for every element. So that'll be linear space. Because I think this is what did I get wrong on? Binary search, don't know. I guess this is just wrong. I mean, this is very wrong. So yeah, and then ultimately I did do basically what we're doing here. So yeah, and I did a +1 instead for development. Okay, but yeah, that's pretty much all I have. Let me know what you think. Stay good, stay healthy, to good mental health. Be sure to leave a comment. Let me know what you want to talk about, and I'll see you later. Bye bye.